from Bali, who has worked in many capacities in all the bamboo projects that is taking place in Bali. So we hear from him straight away. Mr. Ashar Saputra is a lecturer engineer with Gajan Magat University in Yogyakarta, and he's been involved in many of the projects since 2004 till date. You can name any of the good structures in Bali where Professor Aksar was involved, and so I just hand over the presentation to him and let me hear from him, because we are very fascinated by Balinese architectures, Balinese design, particularly in bamboo. So I would like you to speak more on how you have maintained the standards and all those things. Please, Professor Aksar. Yeah.
Thank you, Mr. Salam. I hope my voice is heard clearly.
Yes.
Okay. Thank you, everybody. It's a good honor for me, Mr. Salam, and also the college from the Cheng University in Taiwan. Today, I would like to share my experience, also my difficulties during the construction of bamboo, especially for big building of bamboo. And also, before I start, I'm a structural engineer, and my presentation will be much more related to the structural or civil engineering aspect. So hopefully all participants, I don't know how many participants here who having a background of the civil engineering, because I think it's much more related to the structural engineering. And I will connect my presentation with the standard code, especially for the building code. And at this moment, for me, in my experience, difficult to fulfill all the requirement from the code to the bamboo building. I would like to talk about the bamboo from the beginning, and then I would like to talk about the concern on the some aspect related to the standard code. I will say about the natural period of the building, and also the story drift, flow, vibration, and then I would like to discuss about the limit state design. This is, I think, the core of the standard building code. I will not talking about the material itself, because already discussed by Professor Norman. So probably I would like to jump to the standard building code. Dear guests and all participants, let me start with the nature of the bamboo, which is very engineered from the very beginning. I will cite my Indonesian senior engineer that he stated the percent of the minimum material consumption is identical with the maximum accumulation of energy per centimeter cubic of the material. And this principle is very, very well depicted on the bamboo material. About the shape, about the cross section, about the separators, about the very good to start from this point. And from this fact, I would like to say that it is strongly recommended to use original bamboo shape for the construction. In the consideration of material efficiency, cost, energy, and environment concern, for transforming into the rectangular section through lamination of pressed bamboo open. So I would like to request all the engineer or the architect, please to do design bamboo building using the original shape. If we try to utilize bamboo through the laminated bamboo and also the strand open pressed bamboo, I think it will not match with the requirement about the energy cost and the environment consideration. So let's start with the original shape. Originally, bamboo is already amazing, strong, and very good for the construction. So this is my opening for the understanding about the bamboo. Again, in number one about bamboo, I will start to request to ask the all audience to see the Bali Kite Festival. What can we learn from the structure of these kites? My question when I first saw this kite is that the craftsman or the artisan understand the modulus of the elasticity of the material because it needs appropriate stiffness or flexibility to make that thing flies. If too flexible, cannot fly. If too stiff, cannot fly. So it's kind of balance. It's kind of appropriateness about the mechanical and the physical properties of bamboo. So when I'm thinking about the code, so I'm thinking about the appropriateness. Should the bamboo come to the very standardized or it just come to the appropriateness? How about the bamboo building? Can we learn something from the situation? So this is also make me some kind of insight because after 10 years, 14 years dealing with bamboo, strongly it's hardly difficult to fulfill all the requirement of the standard building code. I will explain the situation uh, case by case, but this situation bring me the understanding that sometimes the appropriateness is have to be fulfilled rather than only fulfill the requirement from the code. So what we would like to talk about standard building code in relation with the bamboo building, I will start with the design life. And then I will start with the fundamental or natural period of building. This is also, all these aspects should be taken into the account during the structural design. And then how about the interstory drift? And then how about the floor deflection and vibration? And how about the wind load? And at last, I would like to discuss about the limit states, which is include the ultimate limit states, serviceable limit state, and also durability limit states. So I think this is very challenging for all of us, especially for the architect and the structural engineer. This is the explanation about the natural or fundamental period of bamboo structure. Actually, many standard building code states or recommended the maximum natural period of building. The ICE 7 standard specifies that building are considered flexible if they have fundamental period greater than 1 second. Tall building or moment frame buildings tend to be more flexible, and also bamboo building because bamboo having lower module of elasticity compared to steel and also concrete. So it's probably very difficult to reach some kinds of appropriate stiffness based to this standard code. So in my experience, it's hard to obtain the such fundamental period for bamboo structure. I will show you in my experience for the Sharma Spring building, 3 stories, and then I get the fundamental period is around 1.8 second. And then for the artist house, Donna's house, and everything, the more organic shape of the building and the more mass on the roof, and then it will be the longer the natural period. So this is the situation. And this natural fundamental period is related to the seismicity and also the wind situation in some region. So for the stiff building, the seismicity or the seismic load will play more important load. But for the flexible building, the wind will be the constraint. So this is the situation when we have to deal with the bamboo structures. So this is the situation. I will show you that if our structure is relatively cubical or regular, like the lodge in the Belgium 2011, you can see the shape of the building is much more regular, and we can get the natural period around 0.3. It's stiff building, and then probably not really affected by the wind load. But for the Sharma Spring in Bali, this three-story bamboo building, it's also constructed in 2011. I got the natural or fundamental power rate around 1.8. So it is flexible. Sometimes if the wind blows relatively high speed, probably some sway will be happen in this structure. And for the artist house, we get more fundamental period due to the heavy mass on the roof system. So we get 2.5, and then this model this situation. So the engineer and also the architect have to give appropriate explanation about the situation, about the design and the natural period of the building. The last one, this is the example of the Nansha exhibition in Nansha Bird Park in Guangzhou, China. I think this is constructed in 2019. This is these pictures belong to WNA Studio, and as you can see, the fundamental period of this building is around 1.5. So this is the situation. So in this regard, once I say that it's difficult to make our bamboo building to become a stiff building, and sometimes the relatively big sway will be received or be seen in our structure. Number one is related to the design life or standard design life. One, this is the picture of the heart of the school, the Green School Bali, and this is constructed in 2008. So right now it's 14 years in service. In 2008, the founder of Green School, Mr. John Hardy, asked me how long this building will survive, how long the design life for this building. And then at that time, I replied that at this situation with the technological and maintenance method that we have, I will say that 25 years is the optimum points. And then Mr. John said, it's okay, 25 years is enough for the calculation of the economic aspect. Once we when we determine the design life, then this will be related to the earthquake load. The longer design life, the bigger earthquake load. And so for the wind load, and so for the snow load. Okay, and also for the vulnerability.
你们看谁办的？
Sorry. Okay, so right now, in normal situation, the standard building code for the public space or the normal building, usually we will only have minimum 40 years design life. But I will say in the situation right now, I don't say it's impossible, but for my experience, 25 years design life will be appropriate in many aspects due to the durability, to the economics, and so on. So let's determine between the architect, engineer, and then the owner about this situation, about the design life. Don't give the information or misinformation to the owner that our building is designed to have service life, uh, let's say 40 or 50 years old, because probably it will be difficult to achieve. The third one that I feel very difficult to fulfill the requirement from the code is related to the story drift or inter-story drift. In the normal situation or the common building, the code states the drift to be 1% or 1.5% or 2% related to the certain or the importance function of the building. Let's say for the hospital, probably the story drift only 1% allowable. But for housing, probably 1 or 2%. For office building, the code usually state 1.5. But in reality, probably it's very hard. Why? Because in this kind of structure, bamboo structure, the connection will be play very important role on determining the inter-story drift. So the nature of bamboo, which having low MOD, 1/200 of steel or half of wood, this has become the challenge, how to get the inter-story drift not to be too high. And then the second one, the problem is related to the property of joint of the connection. So this is the challenge that I'm facing during the construction of this structure, bamboo structures. The next is related to the flow vibration or flow deflection. The vibration of the floor will be related to the strength, the capacity to withstand the load, and also the serviceability. Usually, standard code for the building will state that span per 400 or span over 300. But in this situation, when we design bamboo structure, span over 1400 is almost impossible to reach. And also span over 300 also difficult. Span over 250, I think this is the compromise point. Why? Because if we want to reach span over 400, then the floor beam will be very big. And the architect will say, I don't like this big beam. So at which point we have to compromise? So I will say probably span over 250 is the compromise point. So, but the most easier, and usually I will use this limitation, is about span over 200. It's easier to obtain. I mean, the architect will agree, and then probably some vibration and little bit deflection. But the user also still okay. It's okay, no problem with this kind of vibration. When we're talking about the vibration, actually we will recommend, or in general, concrete or steel building, 4 hertz is the minimum standard, because when one stepping in the floor, this will be not be interact with the natural vibration of the floor. But with bamboo, try to reaching 4 hertz of stiffness, I think this is impossible. So usually we will only try to reach 1 hertz of floor natural period. And I will say this is acceptable once the user or the owner understand the situation. If we try to increase the stiffness, it means I have to put another beam or floor beam, biggest floor beam. So the architect also will say no, the user also will say no. So 1 hertz, I think this is the acceptable floor vibration for bamboo building. This picture is a Millennium Bridge at Green School Bali, already 11 years in service. Previously, at the same time, we saw the bridge constructed by our senior Yoksam, but after that, the bridge is washed away due to the flood, and then I called by the Green School to reconstruct a new one. And this is the calculation, and the situation is I show you that sometimes we have to do arches and also the curve of the arches to be higher to get the steeper floor vibration or the increase the stiffness of the floor. Yes, this is kind of a challenge in structural design, how to match with some requirement of the building code. The next is about the wind load. I try to I contacted with some client, some architect that having the design in the sub-equatorial region, which having the standard load more than 150 kilometers per hour. And when I come to the calculation and I back to the architect, if you ask me to calculate more than 150 kilometers per hour, then I need, let's say, 6 fold of column. So what do you think? The structure will be very bulky. Then architect will say, no, it's too bulky. I don't need any light structure because bamboo should be light. So it's up to you and up to the owners. If I have to take into account more than 150 kilometers per hour wind speed, then your design will be bulky. So it's up to you. Then the discussion is come with the point of agreement that, okay, we can design with 150 kilometers per hour, but we will have to some kind of exit strategy, which is when the wind speed come more than the design speed, some part, usually the roof seating of roof cover will be let be blown away, but the main structure will be intact. And then the user or the owner, okay, I can achieve that. So we can go for the further step for the design. Architect usually agree with that, but the user have to understand the situation about the bamboo calculation, about the done bamboo properties and so on. So this is when we discuss about the wind load. Uh, uh, Ladies and gentlemen, the next I would like to talk about the limit state design for the bamboo. So the limit state design approach considers that the structure should sustain all loads and deformation liable to occur during its construction, perform adequately in normal use, and have adequate durability. What the aspect of the ultimate limit state about the loss of equilibrium, rupture, and so on include fatigue, and for the serviceability limit state, it include the excessive deflection, excessive crack, excessive undesirable vibration that I already discussed with you or presented with you, and some kind of the spatial limit state due to abnormal condition about the durability, collapse, extreme earthquake, and so on, corrosion or deterioration or durability. So how we try to match the situation of bamboo with this kind of consideration. I would like to cite what already Anwar and Najam state in the paper that yes, for the limit state design, usually we will play with the characteristics value of the material as a basic strength of the material, and also this will bring to the material safety, and then come to the design strength, and then we will put the member safety. At the other side, we will try to understand the characteristic of the load, and then we'll get the load factor here, and then we come to the design load, and then we come to the structural analysis factor. So this is kind of what in the evaluation of the standard code, I think we are here in the fifth step of the understanding of the building structure. We are talking about the introduction of the capacity design, capacity-based design approach. But for bamboo, as I explained previously, probably it's really difficult if we have to follow this introduction of capacity-based design approach. What I'm thinking or I propose, I think it will be more appropriate if we do the standard following the performance-based design and more explicit linkage between demand and performance. So in this sixth step of the understanding of the structure, the user, architect, and the structure have to come to one agreement. Which one is the most appropriate, the most desirable? So in terms of economic, risk, and everything, so then the design will become to the most optimum. So probably for the more advanced, the step number 7 probably will be sufficient also for the bamboo standard building, but I think the most appropriate is related to the performance-based design. One thing that we are not taken into account properly is about the connection or the joint on bamboo structure, which is play the most important role on the structural performance. It's hard to get the standardize the performance of the joint, and this is will be affect very much on the performance of the overall structures. And how to include the connection aspect on this standard? If we talking about the material, fine. Professor Normando already explained us about this one. And then I think this become the ISO, Indian standard already have many, but when it comes to the all structures, I think it's not sufficient, or I think it's not enough. We have to do, we have to come to the another approach that in my way of thinking is about the performance-based design. I will explain about the situation about the performance-based design. This is the project that I involved in the development of community center in Buntoy, Central Kalimantan, funded by United Nations Office of Protective Services in 2012. At the time, UNOP sent the ARUP engineers to become a second engineer in service to check my calculation, to check my design. After several hours discussion with the ARUP engineers, they said, how you very sure about the performance of the structure? Then we come to the very short discussion, just to loading test. What do you want me to do? Do loading test. Okay, then we do the loading test. This is the kind of performance-based design. Sometimes the calculation is not very clear, and sometimes it's not very sufficient for other engineer. So this is the way we can ensure that our calculation is sufficient. So this is kind of the loading test I do in the field at 48 hours loading, both in the vertical and horizontal. This is for the uniform floor load. We do also, we will measure the deflection and so on. So this kind of calculation will be easy to understand for many engineer, for many region, because this is just very using the standard principle of engineering. So this is why I'm thinking about the performance base to check the performance, the structural performance of our building. We are not talking about the durability in this performance-based design. So the challenge related to the performance of structures is about connection, because this is again really hard to standardize, and then about the material deterioration to the climate. It is also how to maintain, and it is also have to be discussed from very beginning. The architect have to understand about this risk, about the material deterioration due to the weather. And sometimes, as the previous presenter said about the insufficient or sometimes inappropriateness method during the construction, about the workmanship, about the tool, about the how to avoid splitting, how to everything, because this is need some kind of very good process during the construction. So it's also difficult to standardize. Of course, compared to steel, compared to concrete, we have a very clear standard during construction, but it's difficult for the bamboo structure. And at last, I think the yield material, I think they play the less role for the failure of the structure. So in my experience, I never see that the bamboo fail in terms of material yielding. So this is the less significant aspect when we are talking about the limit state design for bamboo structure. So in my conclusion, that the design of bamboo structure shall be considered the comprehensive design life between owner and designer, and also we have to put the conservative side. Even though the catastrophe, the risk due to the failure of bamboo probably small, because lightweight material of bamboo, and usually bamboo structure will have longer fundamental failure, more sensitive to wind rather to the earthquake. So I think this is a good point if we stay in the seismic prone area, and the approach for proper limit states should be more explored, considering the aspect of economic sensitiveness of bamboo material to the climate and the performance of joint and connection and so on. I think this is the setting situation for me, and thank you very much. And I will give back to Mr. Salam. Thank you very much.
Thank you so much, Professor Ashar Saputra, for your intervention, which I think is very important.